about my experience.
Stupid we are.
Enjoy yourself. Let's talk a bit about the welfare consequences of advertising. Okay, we have more students. One in singular. It's a mince pie at the front, if you want one. Okay, so what Dixit and Norman did back in '78, they were looking at what the welfare consequences of advertising were if you measure advertising with respect to a fixed standard. Okay, so if advertising is going to shift the demand curve, let's either take preferences before the advert or preferences after the advert and see whether advertising is a good thing or a bad thing. Okay, it's not going to matter whether we take preferences before or after. It's going to be a little bit mathsy, but it's always going to help to think about what a demand curve looks like. There's price and quantity. Okay, so we're going to let S of P, be total consumer surplus when the price is given by P. Okay, so if this is the price, then this area here is S of P, right? That's consumer surplus above the price. And we're assuming the consumer surplus doesn't depend directly on the amount of advertising performed. Okay, that's just equivalent to assuming that you're either taking preferences before or after people have seen the advert. We're going to define V of Q as the maximum consumers would be prepared to pay to purchase a total quantity Q. Okay, so V of Q is going to be related to their consumer surplus, clearly. Okay, so V of Q is so if suppose you're buying some quantity Q, how much are you prepared to pay to buy that quantity Q? Well, you're prepared to pay this area in total. Okay. Everything under the demand curve from there up to there. Okay, so V of Q is going to be this integral from 0 up to Q of can't work around V, yeah? Okay, so the demand curve is given by P of Q. Okay, so P, let's say V of Q star, just so we don't confuse ourselves. So this is P of Q, Q dQ. Yes, just the area under the demand curve from 0 up to Q. And what I say here is that it must be the case that V dashed of Q of P is equal to P. Well, this is just what happens when you differentiate under an integral sign, right? So when you differentiate an integral, you just get back what's inside. So V dashed of Q is just going to be what's inside, which is P of Q. So this is in terms of an inverse demand curve. If we write it the other way around in terms of the demand curve, let's suppose that Q equals Q of P. Okay, then this is V dashed of Q of P is equal to P of Q of P, which is just P. Okay, we did just go from working with demand curve to working with the inverse demand curve. So what's this consumer surplus? Well, consumer surplus is this area under the demand curve between above this price line. Okay, so we know that V of Q is equal to P times Q, which is this big box, plus S of P. And that's what I've written here, but just with the price, with quantity is a function of the price. Okay, so we've got S of P So if we add PQ onto both sides, okay, this is S of P plus PQ is equal to BQP. Okay, that's what I've got written here. Okay, and all I've done here is that I've explicitly written the quantity as a function of the price. Okay, so the value of consuming a quantity given by a certain price times quantity given a certain price. Okay, so these are just identities. There's no advertising happening at all here. What happens when we differentiate this identity? Well, what we get is, with respect to price, this is. So on the left-hand side we get S dash to P. On the right-hand side, applying the chain rule to this expression, we get the derivative of the outside, evaluated at the inside, times derivative of the inside. Okay, when we use the product rule on this expression, we get derivative of this times that, which is just Q of P, minus this times derivative of that, P Q dash P. And, well, we've already found out that V dash to Q of P is P. So this is P Q dash to P, but we've got a P minus P Q dash to P there. So these two terms cancel out. So the derivative of consumer surplus with respect to price is given by minus for quantity. So this is always true. It doesn't matter about advertising. Well, you can see it graphically as well, right? If you increase the price, suppose you increase the price by some small interval delta, what happens to consumer surplus? Well, you basically just lost an area that's delta times the quantity. Okay. So as you increase the price, consumer surplus goes down by the quantity. So it's intuitive. Okay, but these relationships are going to be helpful when we go to work out welfare. Rubbing out Merry Christmas. Scrooge. Okay, so we're going to define a few more things. WA is going to be welfare when a certain amount of advertising is performed. PA is going to be the price as a function of the amount of advertising performed. And pi PA is going to be firm profits as a function of the price and the amount of advertising performed. Okay, so this is having chosen, just as a function of price and advertising. So what's welfare? Welfare is consumer surplus plus producer surplus. Okay, so it's S of PA plus, so consumer surplus at some price plus profits at some price given the advertising level. Okay, so if we differentiate welfare with respect to advertising, that's what we're interested in, right? We want to know whether advertising increases welfare or decreases welfare. Then, from differentiating this thing, we're just going to use the chain rule. Okay, so S dash of PA times derivative of the outside, evaluated at the inside, times derivative of the inside. So to differentiate this, do you remember how to differentiate functions and multiple arguments? You would have done this in the first year, but
partial derivatives?
Yeah, so you take the so the derivative of this thing with respect to its first argument times the derivative of the first argument with respect to advertising plus the derivative of this thing with respect to its second argument times the derivative of the second argument with respect to advertising. So here we have the partial derivative of profits with respect to the first argument price times derivative of the inside, say P dash A, plus partial derivative of profits with respect to advertising times derivative of advertising with respect to advertising, which is just 1. So this is our expression for how welfare changes as advertising changes. Okay, at the moment it doesn't tell us very much at all because we don't know what this is, we don't know what that is. Maybe we don't know what these things are either. So we've got to think about, well, if the price is the profit maximizing price, then it satisfies the firm's first order condition, right? What does that first order condition mean? Well, it means that the derivative of price profits with respect to price should equal 0. Okay? If the firm is choosing the optimal price, then this derivative of profits with respect to price should be equal to 0. That's what you do when you solve for monopolist behaviour, right? You set derivative of profits with respect to price to 0. So if a firm is profit maximising, this term is 0. But it's also going to choose a profit maximising level of advertising, right? So if it's choosing a profit maximising level of advertising, derivative of profits with respect to advertising should also be equal to 0. Okay, so if a firm is profit maximising, this term and this term just drop out. So all we're left with is that the change of welfare is given by S dashed evaluated at the price times P dashed. Well, we found out here that S dashed evaluated at some price, so the change in consumer surplus given the current price is just equal to, minus the quantity of that price. So if we plug that in, this thing is minus the quantity of that price. This is just stays as it is, times the change in price. Okay, so the change in welfare as advertising increases is minus the quantity times the change in price. Okay, so the only thing you need to know to work out whether advertising is good or bad according to this measure is whether the price goes up or down. Okay, so if the price goes down, then this is negative, negative, negative makes it positive, so welfare goes up. Okay, so if advertising reduces the price, then it's good for welfare according to this criteria. If advertising increases the price, then this is positive, that's negative, so welfare goes down. Okay, because quantities always have to be positive. Okay, so although it's all very abstract, we haven't assumed anything about the shape of the demand curve, we haven't assumed anything about what consumer preferences look like, but still we have this very simple criteria for whether or not advertising is good. Okay, so this is something that if you were a regulator you could apply into the real world. You know, maybe if a firm starts advertising heavily, just look at what's happened to the price. If the price has gone down, maybe that advertising is a good thing. If the price has gone up, then maybe it's not. Yeah, so I say there's excessive advertising if and only if cutting advertising would decrease prices. These slides we went through briefly at the end of last lecture, so this was all with respect to a fixed standard, so either preferences before or preferences after. And you can argue about whether using a fixed standard really makes sense. If people's preferences are changing, maybe we should use a changing standard. And I showed you this at the end of last lecture. So this criteria with fixed standards was we just have to look at prices. Okay, if we don't use a fixed standard, then advertising generally looks better, right? If you're not using a fixed standard, then consumer surplus has been increased just because of the advertising. Okay, so remember we made this assumption that consumer surplus only depended on the price, it didn't depend directly on advertising. Okay, but in reality consumer surplus depends on advertising. So when advertising increases, consumer surplus goes up anyway. So if you use a fixed standard, you're going to tend to bias your results in favour of advertising looking bad. Okay. When you allow for a non-fixed standard, then advertising is generally going to look better. Okay, so there are going to be cases when prices don't change, but there's still too little advertising. A social planner would still like the firm to perform more advertising. And in fact, there are cases when increasing advertising would push up prices, but still there can be too little advertising being performed. Okay, so that price condition only holds under a fixed standard, and when you don't use a fixed standard, you don't get anything so neat. So there are some sufficient conditions for advertising to be good. Yeah, but they're a bit more subtle. Okay, so the condition is that when quantities are higher, the effect of advertising on prices is smaller. So that's, if you like, it's saying something about the cross effect on consumer surplus. Okay, so when quantities are very large, demand is becoming more inelastic with respect to advertising. And yeah, and if that condition holds, and if increasing advertising increases quantities, okay, then advertising is a good thing. Firms are going to tend to perform too little. Yeah. Okay. So this slide, I try to go through the maths of non-fixed standards, but we're just going to do it for a special case. Okay. Whereas with fixed standards, we can do everything very generally. With non-fixed standards, we have to take quite a special case. So let's take this informative advertising case where we think that quantity is just a multiplicative function of a kind of standard demand curve and an advertising scaling factor. Okay, so the more advertising is, the higher up the demand curve is. Advertising is just scaling the demand curve. What's funny? Do I not want to know?
Read your slides, you should get it. It's just like when you've got f as a function of a and g. That's what she's doing. It just says fag. With a p. It's a fag.
Okay, what was I talking about? Okay, so suppose this is a demand curve. Okay, then how do we work out consumer surplus? Where did I just wrap this out? Okay, price, quantity. Normally we think of consumer surplus, we think of integrating this way. Okay, we go along this line and we take the integral of P of Q, okay, from naught up to some point Q star. Okay, so we're kind of going that way. But we can also go this way, okay? We can think, well, let's go along this line. If you like, we're flipping the chart by 90 degrees. We're mirroring the chart through the axis, and we're taking the integral this way. Okay, so you can write consumer surplus as the integral of quantity from a given price up to infinity. Okay, so here's our P star. We're going up this way, and we look at this height plus this height plus this height plus this height plus this height. Okay, because that's the way Q goes. So this is another way of writing consumer surplus. Well, if we've written consumer surplus like that, we were told that demand curve had this form. Okay, it's multiplicative in advertising and price, so we can separate it out. But then advertising, we're only integrating over price. Okay, so this doesn't have any price term in it at all, so we can take it outside of the integral. So this is just the same as FA times this integral. So that's consumer surplus. Producer surplus is just some arbitrary profit function. Okay, this is just the firm's profits at some price and some advertising level. Welfare is consumer surplus plus producer surplus. So let's differentiate welfare with respect to advertising. Okay, to differentiate this with respect to advertising, well, advertising doesn't occur in here, occur at all in this term, right? So this doesn't change at all as advertising changes. So all we get when we differentiate this with respect to advertising is just the derivative of this with respect to advertising. Okay, so f dash a. And then we get some derivative profits with respect to advertising. Okay, but remember again, if the firm is choosing advertising optimally, this derivative of profits with respect to advertising should be equal to 0. So this term drops out. So the derivative of welfare is just given by this expression. I've got it written down here as well. Well, the integral under this g must always be positive, right? Quantities are always positive. Quantities demanded are always positive. So this is positive, this is positive. G is always positive. The integral of a positive function is positive. So this term is positive. So the derivative of welfare is just as the same side as the derivative of this f function. But if we're working with informative advertising, we think that advertising increasing means demand goes up. Okay, so this derivative must be positive as well. Okay, that's, you know, the effect of advertising on demand must be positive, otherwise firms wouldn't do it at all. So this is positive, this is positive. Therefore, derivative of welfare with respect to advertising is positive. Okay, so when firms are choosing price and advertising optimally, there's still too little advertising being performed. Okay, so with informative advertising, there's too little performed if we use a non-fixed standard. Okay, so a social planner would always like firms to perform more advertising, let more people know about their wonderful product. Okay, let's get that. Yeah, so far we've been quite vague on how advertising actually works. Okay, we've just had a demand curve, we've had advertising entering into that demand curve for some reason. Okay.
Why did you integrate that like that?
Because nice of you to join us. Well, because we're working with a demand curve that's specified as a function of the price. So it's just a lot easier to integrate over the price. If we'd done it the other way around, yeah, it would have been. We would have had to plug in the inverse demand curve, and yeah, it would have been a mess. But this way, it's all very neat. Okay, so rather than having a vague model of how advertising works, just having advertising with demand curve, let's see if we can produce a model in which we understand how advertising is working. So we really have a kind of endogenous model of advertising. And this guy Butters did it in 1977. No relation to the South Park character. So suppose for a large number of firms, okay, infinitely many firms if you want, and they can all produce at most one unit of a good. Okay, it's a slightly implausible assumption, but it's going to make our life a lot easier. Okay, they all have the same marginal cost of C. If you don't like this assumption that there are infinitely many firms each producing one unit of a good, you can think of, you know, one firm producing lots of copies of the good, but maybe setting a different price for each of those copies. Okay, there's going to be no entry cost. That's why we're going to have infinitely many firms. But firms, no one's going to buy from a firm until they receive an advert from them. Okay, if I don't receive an advert from you, I don't know you exist, so I'm not going to buy anything from you. And so consumers have a marginal cost of production of C, but they also have a cost of sending out an advert. Okay, so they can send an advert to a consumer for a cost A. And these adverts, they're pure informative advertising. They're just going to say, I exist, I'm selling the product at this price P. So these consumers, they're not going to shop around at all. If they receive an advert from a firm, and that advert is listing a price below their reservation value, V, then they're going to be prepared to buy. Okay, so V is the maximum consumers are prepared to pay. If they receive an advert saying that a firm is selling the good at a price below V, then they're going to buy from that firm. But if they receive multiple adverts, so if a firm receives adverts from 3 different firms, you know, one with a price of £10, one with a price of £9, one with a price of £8, they're going to buy from the cheapest. They're going to buy from the £8 firm. So it's a very simple model, but it's going to have some nice results. How are we going to solve this model? Well, what we're going to do is we're going to kind of assume the answer and then work backwards. Okay, this is something economists do a lot. You know, make a guess and then prove that your guess is right. Okay, so let's suppose that if you sent out an advert listing a price P, you have a probability X of P that your price is the lowest price that that consumer receives, so the consumer is going to buy from you. Okay, so this is a probability, this X of P thing. It's for probability that you're the cheapest advert that a consumer receives. Okay, you know, some consumers are going to get no adverts, maybe some consumers are going to get 5 adverts. This is the probability that all the adverts the consumer receives, yours is the cheapest, if you set a price P. And clearly the probability can only be a function of the price. Okay, in that case, if you're the cheapest advert that a consumer receives, then the consumer's going to buy from you, he's going to pay a price P, you're going to have a marginal cost of C, so your profits are just going to be P minus C. Okay, you're only selling 1 unit of the good. So this is a probability of you making a sale. This is your profits if you do make a sale. So your expected profits are just the probability times your profits if you make a sale minus the cost of sending the advert. Okay, so the firm's profits are P minus C times X of P, this probability of making a sale, minus the cost of having sent the advert out. So we're going to be a large number of firms. So if you like, there's free entry of firms into this industry. Firms are going to carry on entering until profits are driven down to 0. Expected profits are driven down to 0. Okay, so in expectation, firms make 0 profits. Okay, so if firms make 0 profits, this thing must be equal to this thing. Okay, so it must be the case that P minus C, X of P, is equal to A. Yeah, okay, and on the slide I run through the argument. Well, you know, suppose there was a firm making positive profits in expectation. So that firm must have some strategy. Okay, it must be sending out an advert with a certain price written on it, maybe £11. Well, if that firm can make positive profits sending out an advert listing with £11 written on it, then if I send out an advert with £10.99 written on it, or £10.99.9999 pence or whatever, then any time the consumer receives an advert from both me and the firm that was making a profit, they will buy from me, so I will make a profit. And any time they receive an advert from only one of us, they will buy. Okay, so I will make strictly higher profits than the original firm making a profit. So if one firm was making a profit, by kind of copying their strategy but just slightly undercutting them, I can also make profits. So another firm would want to enter. Okay, so, but when that second firm enters, the first firm is now making lower profits, right? Because now there's a time when that first firm doesn't sell. So their probability of a sale must have gone down. So as more and more firms enter, the probability of sale goes down, and eventually the two things must be equal. Expected profits must be 0. Okay, so cost of sending an advert must be equal to profits from sending an advert conditional on someone buying from you times the probability of having that, of being the cheapest price. Okay, so if we divide through by P minus C, we have that X of P must be equal to A over P minus C. So this mysterious thing, X of P, which we just guessed to start with, we now have a formula for it. Okay, but this must be a probability. We started by saying X of P was a probability. Probabilities go between 0 and 1. So, in particular, it can never be bigger than 1. Right? You can never have a probability bigger than 1 of anything. Okay, so if X of P is going to be less than 1, then A over P minus C must be less than 1. So A must be less than P minus C. Okay, so P must be greater than A plus C. Okay, less or reasonably less. So all firms must be setting a price that's higher than A plus C. Well, that makes sense, right? C is their marginal cost of producing a unit of the good. A is their marginal cost of sending an advert. So in order for anyone to buy, that person must have seen an advert. So the price should certainly be bigger than A plus C. So as long as everyone's setting a price above A plus C, the probability of the probability that a given price is the cheapest that the consumer receives will be less than 1. We also know that no one's going to buy if the price is bigger than V. Okay, V was the consumer's valuation for the good. Okay, so it must be the case that x of V should be equal to 0. Is that the right way of doing it? Okay, so x of V, just plugging in V into our formula for x of P, we have that there's P only goes there, so x of V is A over V minus C. We assume to start with that the consumer's valuation of the good is higher than the amount it costs to produce the good. So this is positive, this is positive. So there's a positive probability that if you set a price equal to the consumer's valuation, consumers will still buy from you. Okay, so this must be the maximum price that firms are setting, and firms that are setting this maximum price are still going to be making a sale. When is a consumer able to make a sale at that price, for a price V? Well, if they receive 2 adverts, one of them will be less. If one of them is less than V, they'll buy from the one that's less than V. So the only way a firm can make a sale at a price equal to V is if the consumer only receives 1 advert. Okay, so this fraction, A over V minus C consumers, it must only be receiving 1 advert. So what's going to happen then, firms are all going to set different prices, but they're going to set prices at every point between A plus C and V. Okay, so there's going to be some distribution of prices. Which way is it going to slope? Not sure. And firms are setting every price between those intervals. Okay, so if you like, firms are kind of pricing randomly. They're sending random prices out in these adverts, but the distribution of prices is given by this formula. Or the distribution, so you can back out the distribution of prices from that formula. So this probability of making a sale if you set a certain price, it's a bit like a demand curve, right? You know, expected profits for price minus cost times this X thing. So it's a bit like a quantity. So it's like, if you like, it's the expected number of sales you'll make. So it looks a bit like these firms are monopolists. You know, they face a demand curve, they're choosing an optimal price based on their demand curve. Okay, so you might expect that this is horribly inefficient, but it turns out that this model, the competitive outcome is efficient. Why is that? Well, normal thing, price is a transfer here, so it's irrelevant. If firms set a high price, it just means consumer surplus is low but producer surplus is high. It doesn't make any difference. You know, it's only the quantity margin that's going to make a difference. How much does society care about reaching a new consumer? Well, the value to society of another consumer getting an advert is V minus C, right? V is the consumer's valuation, C is the cost of production. So society would like to equate the cost of sending out another advert with this benefit to sending out another advert. Okay, so what's the cost of sending out another advert? okay, sorry, the cost of sending out another advert is A. The benefit of sending out another advert is V minus C times the probability that that consumer hadn't already received an advert. Okay, if you send out an advert, there's a high chance that it hits someone who's already seen an advert, right? What's the probability that a consumer hasn't seen an advert before? Well, as we said before, it must be A over V minus C. Okay, so the total social benefit is V minus C times A over V minus C. Well, that's just A. Okay, so the expected social benefit of sending out another advert is just equal to the social cost of sending out another advert. So the social planner would choose the same amount of advertising as with firms. But this only holds when all consumers value the good the same amount. Okay, if consumers value it differently, this will no longer hold. Okay, so let's. Do you want me to just push through rather than having a break so you can leave very early?
How long would it take?
We're not far enough, are we? This is the last bit of maths, isn't it? Yeah. Okay, good. Okay, so last mathsy model of this semester. Let's combine the hoteling model with the butters model. That's basically the punchline of what we're going to do. Okay, so here's our hoteling line, 0, 1. We're going to have two firms. Firm A is going to be here, firm B is going to be there. Linear transport costs, so cost T per distance, 0 marginal costs. Firm A is going to send adverts out to a proportion ZA of consumers. Okay, so the firm is kind of sending out thousands of flyers. I don't know, if you live in Guildford, you probably get millions of flyers from estate agents. Every day I seem to get a new flyer from an estate agent trying to sell my house.
Where do you live?
Pardon? Daptune Road?
In town?
In the centre of town.
Oh, okay.
Millions of them. I think I've got students across the way from me. I hope none of you live too close. Okay, so the firm is going to send out adverts to a proportion ZA of all of the households. Okay, so these consumers are going to be, consumers who get the flyers are going to be randomly distributed over a line. Okay, so it might be consumers here and here. And, you know, in total, a proportion ZA of them are going to receive an advert. There's going to be a cost to sending out the adverts of R over 2 times ZA squared. Okay, so R is just some scalar that just controls how expensive sending out adverts is. ZA was the proportion you're hitting. Okay, so the cost of sending out adverts is proportional to ZA squared. So it's proportional to the proportion of consumers who receive an advert squared. And we're just making this technical assumption that naught is less than R is less than that thing. Okay, these adverts are randomly distributed over the consumers. So although firm A is here and firm B is there, it's not the case that firm A's adverts are going to be concentrated close to firm A. Some of firm A's adverts are going to be going way over to the other side. So a proportion. What's the probability of not receiving an advert from firm A? Well, that's 1 minus ZA. What's the probability of not receiving an advert from firm B? That's 1 minus ZB. So in total, 1 minus ZA times 1 minus ZB of consumers, that proportion, will receive an advert from neither firm. Okay? So if you receive an advert from neither firm, you don't know the firms exist, you're not going to buy the product. If you receive an advert from both firms, then you're going to have a choice of whether you walk left or right, and you're going to choose based on, you know, your laziness, standard hoteling things. Okay, so the consumers who receive an advert from both firms are going to act like standard hoteling consumers. There's going to be some indifferent consumer, and just like the standard hoteling model, the indifferent consumer here is going to be at this point. Okay, this is the expression you've seen before, half plus difference in prices divided by 2 times the cost of transportation. So what's the demand faced by firm A? Well, a proportion 1 minus ZB don't receive an advert from firm B. Of those, a proportion ZA receive an advert from firm A. So this proportion, receive an advert from firm A, don't receive an advert from firm B. If you only receive an advert from firm A, you don't know firm B exists, then you're always going to walk to firm A. Okay, so this gives an inelastic demand bit to the demand facing firm A. Then some consumers are going to receive an advert both from A and from B. Okay, what proportion? Well, ZA times ZB. And of those guys, well, if X star is here, this people on this interval are going to buy from firm A. Okay, so you get ZA, ZB, that's the proportion you receive an advert from both. X star is the proportion of those who want to walk left rather than right. So if that's your demand curve, what are you going to do? Well, you want to maximize profits. So profits are, here's our quantity again. So we've just rewritten the previous expression. We've taken ZA out as a factor. We've plugged in for X star. That's giving us everything up to the end of that square brackets. Okay, that's just what we had before, just plugged in for X star. So this is quantity times price minus cost of sending out the adverts. Okay. So the firm is going to choose both the amount of advertising and the price to set. So there's going to be a first order condition for the amount of advertising. And so ZA occurs here, and it occurs here. Okay, so when we differentiate this with respect to ZA, we get all of this. So ZA is here, and then not at all in this expression. Okay, so when we differentiate this with respect to ZA, we just get everything else. Okay, so here's everything else, and then we get the derivative of this with respect to ZA, which is just minus R times ZA. Okay? So ZA must be equal to this thing divided by R. So that's the first order condition for advertising. There's the first order condition for price as well. PA occurs here, it occurs here, and that's it. Okay, so we're going to do the product rule. So derivative of this times all of this. So here's that bit. And then we get this times the derivative of all of this. Okay, so PA times the derivative of this, which is ZB minus 1 over 2T. Okay, ZB minus 1 over 2T. So now we've only got PA here, well PA here and there. Let's just take PA over to the other side. We get some expression for PA. And then we get to cheat a bit. We know the model's symmetric, so we know that firm A and B must be setting the same price. We know that firm A and B must be performing the same amount of advertising. Okay, so if we let P be equal to PA and PB, Z be equal to ZA and ZB, then this term is going to drop out, right? Okay, that's going to drop out, so things get a bit simpler. So we can, what we're left with is ZA is equal to PA over R plus 1 minus ZB plus ZB over 2, because that bit's dropped out. And that's just, so 1 minus Z plus half Z, so that's the same as 1 minus half Z, that's what we've got here. Likewise for the price, this term drops out if PB is equal to PA. So we have 1 minus ZB plus half ZB, that's 1 minus half ZB. Okay, so the price is given by this expression. So we've got an expression for Z, we've got an expression for P. We have to combine the two in order to get a solution. The nice thing is that we've written it in a way that they have this common factor. Okay, so if we take this expression and we divide it by the other expression, so what we're doing, if A is equal to B and C is equal to D, then A divided by C must be equal to B divided by D. So I think that's what I'm doing here. So let's just do that. So we have Z divided by P is equal to P divided by R all divided by 2T divided by Z. Okay, this bracket and this bracket just cancel out. Okay, so this, let's rewrite this right hand side. We've got a division on the top, we've got a division on the bottom, so we can flip those sides. So this is 2p, is this a 2 or a z? It's a z, isn't it? So zp divided by 2tr. Okay, now we've got a z here and a z there. So those cancel. And what have I done? Rz over p. Yeah, okay. What am I going for? Pz over 2t is what I'm trying to get to. So here we've got pz over 2t. So we just need to take the r across. So rz over p is equal to pz over 2t. Okay, we just multiplied by r. There's an r there, we just took the r up there. And that's what I've got on the board, isn't it? Yeah. Okay, so p's there. We take the p up there, so this becomes p squared. We can divide through by z, so the z's disappear. We can multiply by 2t. So 2tr is p squared, so p must be equal to the square root of 2tr. Just on the board. And then once you've found p, you can do the same thing to find z. You just plug in. Okay, the algebra is a bit tedious. It's the last day of term. I'm going to skip going through it. Turns out z is given by that expression. And there are some technical conditions. Let's just see if this makes sense. So the price, well, it's increasing in transport costs. That's normal. We normally get that. It's also increasing in the cost of advertising. Okay, if it's expensive to send out adverts, then people are generally going to send out fewer adverts, meaning demand is more inelastic, means you can get away with setting a higher price. So that makes sense. Advertising is decreasing in the cost of advertising. That makes sense. If advertising is cheap, you might as well do more. And it's increasing in transport costs. If transport costs are high, then demand is inelastic, which means there's more benefit to sending out an advert. And you can plug in for profits. Again, the algebra is horrible. So let's try and finish. You get some expression for profits. Okay, so what does this tell us about the world? Well, so remember in the basic hoteling model, the price was equal to T. Okay, so the basic hoteling model we had price equal to T. Here, for this to make sense, we need Z has to be less than 1, okay, because Z is the proportion of consumers that receive an advert. Okay, proportions have to be less than 1, otherwise there wouldn't be an interior solution anymore. Okay, so for this to have an interior solution, Z must be less than 1. Well, for Z to be less than 1, this thing on the bottom must be bigger than 2. Right? If we've got 2 on the top, something on the bottom has to be bigger than 2 in order to get Z less than 1. So this thing in the square root has to be bigger than 1. Okay, so 2R has to be bigger than T. Okay, which means R has to be bigger than T over 2. So, if there's going to be an interior solution to this model, okay, when not everyone is receiving an advert, then we must have R bigger than T over 2. But if R is bigger than T over 2, then R is bigger than T over 2, then 2 times R is bigger than T. 2 times TR is bigger than T squared. So square root 2 times TR is bigger than square root T squared, which is T. So, if this condition, if R is not bigger than T over 2, there's not an interior solution. Okay, if R is smaller than T over 2, if advertising costs are very low, the firms just send adverts to everyone, and the model's not very interesting. Okay, when R is bigger than T over 2, so there is an interior solution, then what we've shown is that square root 2TR is bigger than T. Square root 2TR was the price the firms are selling in this model. T is the price they're selling in the basic hoteling model. Okay, so what we've shown is that the need to perform advertising has increased the price. Because some firms aren't getting the good at all, the price is going to be higher here because there's an inelastic component to demand there. If we looked at this expression for Z, remember we said that Z was increasing in T. Okay, as T gets bigger, this thing gets smaller, so this whole thing gets bigger. Okay, so when products are differentiated, there's going to be more advertising taking place. Okay, so we expect more advertising in differentiated markets than in homogeneous markets. This is maybe slightly surprising, right? You'd think that with homogeneous products you might like to advertise in order to differentiate yourself. Here, yeah, I suppose we kind of ruled that out in the construction of the model, right? This is pure informative advertising. It's not like the advertising is a complementary good to either of the two products. Okay? If we allowed advertising to be a complementary good, then we might get different results. But with informative advertising, if everyone's producing the same product, there's not much point you advertising because you know your profits are going to be very low anyway. You're not going to be able to cover the cost of that advertising. And what do I say here? So, you know, we might observe, say, higher differentiation in industries with lots of advertising. Okay, so if you looked at the data and you saw, look, this industry has lots of advertising and it has very high differentiation, it has very high markups. You might think that it's the advertising that's causing the high markups, and the high degree of differentiation. Whereas here, it's not that the advertising is causing the high degree of differentiation, the high degree of differentiation is causing the high amount of advertising. Okay, so you have to be a little bit careful about interpreting the empirical evidence in light of this. Okay, it's not necessarily that advertising is being used to differentiate products. It could just be that the products were differentiated to start with, and that means that firms want to perform more advertising. What we skipped in this messy profit calculation, you know, this was the final figure for profits that you can get to if you can be bothered. And remember, R is the cost of advertising. So this bit is increasing in R. This bit is decreasing in R, but it's going to be dominated by the bit on the top. Okay, so it turns out that when advertising is expensive, profits are higher. So normally, if costs are high, you think profits might be lower. Okay, when advertising costs are high, profits actually increase. That's because if advertising costs are high, firms send adverts out to a lower proportion of consumers, which means more consumers only get an advert from one firm, and to those consumers you can charge an infinite price. You know, it's like demand is perfectly inelastic to those consumers. Taxing advertising might not be a bad thing. Might be a bad thing, that's the conclusion. Sorry. If you tax advertising, increase the cost of performing advertising, consumers get fewer adverts, and the prices shoot up. So it can be very bad for consumers. According to this model, advertising cost and product differentiation are going to have the same effect on profit. So product differentiation also pushes up products because it means profits, because it means demand is more inelastic. Okay, so both increasing advertising cost and increasing the amount of differentiation in the market are going to increase profits, but they're going to have opposite effects on the amount of advertising performed. So if we look in the data, and you know, maybe one study says there's a positive effect, positive correlation between profits and amount of advertising, and another study says there's a negative correlation between those two things, we shouldn't necessarily be too surprised. Okay, there are two different mechanisms going on in the model, so we can generate any combination of the effects. Okay, we can generate both a positive correlation between profits and advertising and a negative correlation, depending on which of the two things is more important. And you can show that there can be too much or too little advertising in this model. So the key condition is that when advertising is reaching a new consumer, so just as in the Butters model, the key thing for welfare is for value. So price is a transfer, gain and social surplus, total welfare, has to come from reaching new consumers. Either from reaching new consumers or reducing costs wasted in advertising or in transport. Okay, so reaching a new consumer is good for welfare here. And firms don't necessarily, they don't internalize this benefit of reaching a new consumer. If a firm sends out an advert, it doesn't know if that advert is going to hit a consumer who's already seen an advert or one who hasn't seen an advert. So the firms, from that perspective, are likely to send out too much advertising, okay, because they can't target adverts at people who haven't seen them already. So that's kind of the non-appropriability effect that we've seen before, but there's also a business stealing effect here as well. If you send out lots of adverts, it's like moving closer together, right? It increases your demand. And firms have an incentive to do too much, to take too much demand. Okay, so these are the models of informative advertising. If you like, the Dixit-Norman was a kind of persuasive advertising world. Okay, that's why one justification for using fixed standards was if you think advertising is persuasive, it's changing preferences in a way that preferences shouldn't be changed. Okay, then you want to use a fixed standard. So we've seen a persuasive model, we've seen an informative model. For complementary models of advertising, really you can just take either a persuasive model or an informative model and just relabel things. So, you know, if you want to do it formally, yeah, you specify utility functions in which seeing the advert and receiving the good are complementary of the utility function. And you can remember from second year micro what the difference curves must look like for that to be true. But yeah, really what you end up with is going to look a lot like either a persuasive model or an informative model. So here's one. Well, suppose that if I've not seen an advert, then I value the good at 0. If I have seen an advert, then I value the good at some amount v. Okay, that looks a lot like the setup of the Butters model. Okay, whereas in the Butters model, everyone wanted the good to start with, and we calculated welfare based on that assumption. If you just reinterpret things, relabel things as people just don't value the good until they see the advert, then it's still the same setup, but you're going to get different welfare conclusions. In the Bunner's model, you got the socially optimal amount of advertising being performed. If the true setup was this complementary framework, would you have too much or too little? Or just the right amount of advertising?
You should have too little.
Too little? Any other views? So, you know, if people who haven't seen an advert value the good at 0, the only way you can get an increase in welfare is if somehow the good was being sold below marginal cost. Okay, given the good is going to be sold above marginal cost, once people start sending out adverts, you've got this big welfare cost just going to nowhere, the cost of sending out the adverts, and in the end, you know, price is a transfer, that there's no welfare gain from the actual transfer of goods. Okay, so when no one sends out any adverts, welfare is 0. You can't possibly do better than 0 by starting to send out adverts. Does that make sense?
Surely, if the cost to produce is less than Z.
Yeah, it depends on V, sorry, doesn't it? It depends on V and Z.
So V is less than
yeah, you're right. No, so we can be good. I've got that wrong. So assuming V is bigger than C, you send out an advert.
AC, really.
Pardon?
Bigger than AC, A plus C.
A plus C, yeah, okay. I was paying attention. Yeah, you send out an advert and people are getting better off.
But then for the value, you have to include the probability that not everyone's going to see it for it to be greater than the cost to actually make well or not. Because if you're sending out an advert and people don't see it, then you just lose.
Someone always sees it. It just matters if that person has already seen an advert or not. That's the key thing. I thought it was clear, but maybe it's not so clear. Okay, so the argument in the Butters model was social benefit to reaching a new consumer, if you could do it for sure, would be V minus C. That's still true, isn't it? Nothing's changed about that. Okay, so in fact the conclusion would go through as well, I think. So it would still be efficient. Yeah, so any model of informative advertising you can reinterpret. Okay, in that case it looks like the conclusions don't change. Sometimes the conclusions might change. Likewise, models of persuasive advertising you can also reinterpret as complementary ones. Here we go, we're nearly there. So on the empirics of advertising, which might be useful hypothetically were you to write an essay question in the exam, well, read Bagwell. So these are all links, these yellow things, you can click on them. It's a bit late to tell you, but so a few studies. So this guy found that eyeglass prices were higher when advertising was banned. Okay, that seems like an informative advertising story, right? If people don't know about the good, then you can get away with. People don't know about your rival's goods, so demand is more inelastic, so you can get away with setting a higher price. These guys found a similar thing for optometrists. I don't know why they used. I think there must have been some regulatory change in some country which made this possible. And these guys looked at liquor price advertising and found the only goods where the price went down after the ban in advertising was those where the good was being advertised. Okay, so if a good is being advertised, your rival's good is being advertised. Your consumers know about your rival's good. When advertising is banned, your rival's good is no longer being advertised. You can get away with cutting your price. Does that make sense? Pardon?
Why cutting them higher?
Yeah, that's why I paused.
Because you don't have a lot of people.
Yeah.
Independent.
You know, it's
Yeah, that's
Yeah.
so. So you were advertising.
If you advertise your price, if you cut your price, you should be lower than everyone else's price, so more people will come to you.
Yeah.
And if someone else is advertising their good, if you cut your price below their advertised
Oh,
price.
sorry, I misread the whole thing.
They
It's
come
the
to you.
end of a ban. It's not the start of a ban. It's not advertising being banned. It's an advertising ban being lifted. Okay, okay. So advertising was banned. Suddenly, people are allowed to start advertising. Some prices go down. Which prices go down for products that people are advertising? Because you know, before, the people who were buying your good were people who already knew about your good. You know, for people who always buy a certain brand of whiskey, okay, maybe Macallan. You know, there's some dedicated Macallan whiskey drinkers, and no one else has heard of Macallan. Okay, suddenly whiskey advertising is allowed. Now Macallan starts advertising in order to persuade extra consumers to buy, to increase their demand, but they're also facing now competition with, I know, Glenfinnan, which isn't very nice. So they have to cut their price a bit in order to appeal to these extra consumers who've now been brought in. So that's kind of consistent with, these are all consistent with the informative view. And then these papers look at the relationship between product differentiation, profits, and the amount of advertising. Okay, and they get, if I remember right, they get opposite results, but that's kind of consistent with what we said about the hoteling plus advertising model. This paper says, yeah, there's some inverse U relationship between concentration and advertising. So that's like product differentiation and advertising, which is kind of consistent with what we said from the hoteling model. Okay, there's not going to be a clear relationship between advertising and differentiation. So to summarise, advertising is not all bad. There's something to go for all three views, but economists tend to not like this persuasive view because they don't like the idea of people changing preferences. It's very hard to say much from the empirical evidence because really all these things are changing together. Everything's endogenous in economics, so it's very hard to get clear causal statements of one thing causing another. Maybe you can find something else. Okay, let's go. Happy Christmas. Merry Christmas.